Module 2 Overview, Linear and Exponential Functions by Emily Fleming. Review. Domain is x values while range is y values. Geometric sequences have a common ratio and arithmetic sequences have a common difference. Discrete versus continuous functions, Part 1. Discrete. A series of points or a function that aren't connected. Like these points here, they are not connected. In this function, we don't want to include the decimal and fractions. These points will always be whole numbers. A whole amount of something. So here's an example of a discrete. Tickets sold at a dance or balloons at a county fair. You can't have half of a ticket and you can't have half a balloon. And like I said before, here is an example of the graph. And we do not have any connected points, and they're all standalone points. Discrete versus continuous functions, Part 2. Continuous. A series of points or a function that are connected in a line or curve. So just like this graph here, you just have a straight line or a curve that is continuous. It is not separated, they're all together. So here's an example. Your height, your weight, sea level, they're always changing, even if you can't see it, and they just continue on in the data. They do not be by themselves. They're continuing. Continuing. Linear versus exponential functions. Here is linear. On a graph, a linear function would be represented as a straight line. It's always arithmetic. There is no exponent, and this is what a graph would be. This line is straight, and it is linear, just like the word line. Exponential. On a graph, an exponential function would be represented by a curved line. This graph here shows a curved line. Even though it is not as dignified as other lines could be, it is definitely curving, and it's exponential. An exponential function is always geometric, has an exponent, but I will explain it if it doesn't have an exponent. And then let's do examples for both, for linear. So every day Sally goes to the local farm and gets 3 eggs. So basically she is adding 3 eggs, that's arithmetic. And because it has a common difference of 3. So here's a graph that I showed before. It goes up 3, and this unit here is day, while this is the amount of eggs. 3 for the first day, sorry about that, 6 for the second day, and so on. And that is a linear. And then exponential, here's an example. So every single year, every single year the price of collectibles triples. So you can see here, the first year it's third 3, and then it triples to 9, and so on and so forth. It triples in, 3 is the common ratio, so this is exponential. So how do you represent linear equations? Let's see, there's 3 different ways to represent a linear equation. There is slope-intercept form. You might recognize this from last year's math class or some other time. So it's y equals mx plus b. That sounds intimidating, but it's quite simple. M is the slope, while b is the y-intercept. If you don't know what the y-intercept is, it is basically where the line or curved line is passing by on the y. And so let's find the slope for this. So you can see it rises 3 and goes over 1, and that equivalents to 3. And then the b is 1, even though it's not exact, it was meant to be 1. So the m is 3 here, and the b is 1, and that is slope-intercept form. What is point-slope form? That is simple. It's a little bit more intimidating. Y minus y1 equals m parentheses x minus x1. So m is the same, it's slope for x1, and then for x1 and y1, you put the coordinates given in your problem. So if you were given here 1, 3 as your coordinates, you put the 1 here, that's the x value, and the y1 would be minus 3 here, and the slope, like I said, is 7/8, and that is point slope form. The last one is less common, recursive formula. We have already learned this before, but here's a review anyways. The D is the common difference, whether it's negative or positive, and A is the first term, or the term that matches up with the F of whatever number it is in the case you're using. Then here is how do you represent exponential equations? There's only two ways. It makes it a little bit easier to figure out. Explicit form is y equals ab squared x. So b is the constant ratio and a is the y-intercept. Recursive formula, that is a review again. So it's basically the common ratio, and then the common ratio is the r, and then the first term in the a is first term in the sequence, or if this was f of 0, it would be the 0th term in the sequence. Now, I said before that exponential equations have to have an exponent. Now, why does the recursive formula not have an exponent? That is because you have to multiply the ratio, so you do know that it is geometric, not arithmetic, by that difference. So let's practice. So Daisy owns a flower shop. For promotional purposes, she gives away 5 flowers on the start of every month and 1 every day following. So let's see, is this discrete or continuous, linear or exponential? It is discrete because she is giving a amount of flowers. She is not giving parts of flowers. And then is it linear or exponential? It is linear. It is linear because this is arithmetic. It is going to be the same every single month is going to have the same amount, and it's going to be linear. So let's put it into math form. I didn't hide this very well, as you can tell. But you might be confused why I changed the letters to F and D. The reason is we're trying to figure out the amount of flowers, and you get 1 a day. So you can change up the letters to match with the problem. Okay, let's go to another practice. So Wally decides to invest in retirement. He puts $1,000 into his account, and then he earns 7% of his payment in interest every year. So is this discrete or continuous, linear or exponential? This is continuous because it continuously gains. And it's also exponential because it is multiplying each year, which is a common ratio, which means it's geometric, and it goes exponentially on a curve. So let's put it into math. Here, we're going to be using explicit form. So y equals ab squared x. So the first term is 1,000 because he starts with 1,000, and then 7% into a decimal is 1.07 because you have to multiply what you already have plus 0.07 to figure it out. And that is the equation for Wally's investment in retirement. So I really hope you learned something from this video. I hope it was helpful, and I'm glad you stayed to the very end because now you understand discrete, continuous, linear, and exponential. This will definitely help you out in the math world.